All right, so I got two questions today, so I'm going to start out by answering them first. First one was to work in another example of Hess's Law. So what we'll start with is actually the one that was on the discussion board. So I'll bring it up, make it a little bit easier to see. In this case, we have lead plus sulfur goes to lead 2 sulfide with a delta H minus 96.6 kilojoules per mole. The second reaction, the lead sulfide plus O2, 2O2, goes to lead 2 sulfate. This has a delta H of minus 923.1. Third reaction, sulfur plus oxygen goes to SO2. This has a delta H of minus 296.8. And the reaction we're interested in studying is lead plus sulfur dioxide plus O2 goes to lead 2 sulfate. So there's two approaches we can take with this. One is to do the Hess's Law, the other is to add and subtract. Again, both options will be available to you in the exam. The more practical one, the one that's actually used in like the real world, is writing out the Hess's Law expression. So Hess's Law, it's always products minus reactants. We're going to treat each molecule as if it has its own enthalpy and its own Gibbs energy. So for the first reaction, delta H, the heat of lead sulfide minus the heat of lead plus the heat of sulfur, and this is going to equal minus 96.6. For the second reaction is the heat of lead 2 sulfate minus twice the heat of O2 plus the heat of lead sulfide, and this is going to equal minus 923.1. Last reaction, delta H, equals the heat of SO2 minus the heat of sulfur plus the heat of O2. This is going to equal minus 296.8. And what we want to know is the delta H of this reaction, which is the heat, lead 2 sulfate, minus heat of O2, plus the heat of SO2, plus the heat of lead. So if you're going to solve it by doing the Hess's Law expression, it always starts out the same way. Underneath each reaction, write out the enthalpy of the products minus reactants, or the Gibbs energy of the products minus the reactants. Make sure you're multiplying by the coefficients. So there's a 2 in front of this O2, so there's a 2 in front of this enthalpy of O2. This is going to be true of every reaction you run. So that's your first step. Second step is you want to go through and cancel out anything that's going to be 0. So diatomic gases and pure elements. Now, caveat I always put on this, diatomic gases and pure elements aren't the same thing. So if you have something like oxygen O and ozone O3, those aren't 0. Only O2, H2, N2, I2, F2, Cl2, Br2, I2. The diatomic gases are 0. And then anything else on the periodic table that appears by itself. So I've got lead. It's by itself. That's going to be 0. Sulfur's by itself. That's 0. O2 is a diatomic gas. That's 0. PbSO4, these are 3 elements formed together. These are their bonds are being made or broken, so the delta H here is not 0. Same thing's true of the lead sulfide, the PbS, this is not 0. Down here, the SO2 is non-zero, but the sulfur and the O2 are. And down here, the O2 and the lead are both 0. So what I can do is I can cancel out, or I can simplify these expressions. And when I simplify it out, I get the heat of formation of SO2 is minus 296.8. So I'm just going to put this down here, minus 296.8. Gives me the heat of formation of lead sulfide is minus 96.6. So PbSO4 minus negative 96.6 will equal minus 923.1. So I can solve for the sulfate, and I get that the heat of formation of lead sulfate, negative, subtract off, 7. Should be minus 101 point, should be that range, minus 1019.7. I'm just going to stick that number down here in this expression, and when I finish it all up, I think it's like 722.9 kilojoules per mole. So that's one approach, write out the Hess's Law. The second is to add and subtract. I do not advocate this method. This is not done in practice, but it is commonly taught by chemistry 1 instructors. To do that type of analysis, you're going to add and subtract the reactions to figure out how to get them to get to this reaction. So a PbSO4 here, a PbSO4 here. So if I look at it, since they're on the same side, I'm probably going to add this one. I have lead here and lead here. Since they're on the same side, I'm going to add this. And because I have SO2 here and SO2 on the wrong side up here, SO2 is on the right side, this is on the left side, I'm going to subtract this side. So the first thing I teach is figure out the signs, plus, minus, plus. I have one lead sulfate, so I'm going to add this reaction once. So now lead 2 sulfates are taken care of. For the SO2, I've got 1 and 1, so I'm going to subtract it once, that takes care of that. For the lead, I've got 1 and 1. That checks out. Now I just need to make sure everything cancels out. So in terms of the O2s, I subtract the O2s, so that's going to cancel that one out. In terms of lead sulfides, those cancel out. In terms of the sulfurs, those cancel out because I've got a minus here. Everything works out in terms of balancing elements, so that gives me delta H1 plus delta H2 minus delta H3. So I have one other homework problem to go over, and then I'll go over the chat questions. So the homework question I got asked about, KQ from concentrations. And we're looking at number 3. I'll share my desktop with you. You're given the reaction zinc hydroxide, or zinc 2 hydro, no, zinc hydroxide. Goes back and forth to Zn plus 2 hydroxide AQ. And you're given that at equilibrium the concentration of zinc is 1.44 times 10 to the negative 6 molar. And what you're being asked to find here is the KSP. So to solve this type of problem, again, you need IC tables, you need all those expressions. So KSP equals Q. Q in this case is the concentration of Zn plus 2 times the concentration of hydroxide squared. For my IC table, CEE. I don't need to worry about the zinc hydroxide. It's a solid. It's not going to impair my expression for Q. Not given any starting concentrations. The change here is plus x. Change here is plus 2x. So my n value is x and 2x. And I given the concentration of zinc is 1.44 times 10 to the negative 6. So 2 ways I can do this. One, I can just apply this row in. The second row, and I get that this is x times 2x squared, which is 4x cubed. These 2 rows are equal, so x equals 1.44 times 10 to the negative 6. Another option, since these 2 rows are equal, I can determine that this concentration is just twice this one, so it's 2.88 times 10 to the negative 6. And I can stick these rows directly in here. The big thing is remembering to square it when you get done. And when you do finish it off, you should get the 1.2 times 10 to the negative 17. So for the discussion board problem about KSP, this was actually a mistake I made when I was giving the presentation yesterday. So I'll share the desktop really quick. So the KSP of aluminum phosphate is 9.84 10 to the negative 11, 10 to the negative 21. So the reaction I wrote was actually for aluminum calcium phosphate, not aluminum phosphate. Aluminum phosphate is AlPO4, going back and forth to Al plus 3, and PO4 minus 3AQ. So again, to solve any type of problem, I'm going to need to set up my expression for Q and KQ. So I get that KSP equals Q, which is concentration of aluminum, times the concentration of phosphate, PO4 minus 3. My IC table, again, I don't really need the solid. It doesn't appear in my expression for Q. So I've got aluminum, phosphate, ICEE. I'm not given any starting concentrations. The changes are both X. And what I'm being asked to find in this problem are the equilibrium values here. So I'm just going to need to stick in my values for X. I get X times X. So my extended reaction here is the square root of KSP. So whatever the square root ends up being, that's going to be my extended reaction. And for both, they're both equal to the extended reaction. Now, if this was a 2 for some reason, so I had 2 phosphates, I would have to double the concentration, but that's how you end up getting the concentrations. You wouldn't need to multiply by the 2 because there are no 2's in these equations. This first row and the E row are equal to each other. This is an algebraic expression. This is a numeric expression. So basically we get that this is the concentration of aluminum. So X equals the concentration of aluminum plus 3. And here X equals the concentration of phosphate. And I think I had one other question about now for the ethics case study. I'll actually show you how to find it on Blackboard. You may or may not be able to find the ethics online. Sorry, I didn't realize I still had it on the desktop. So, in terms of the discussion board, this is the problem. When you work out the ICE table, you're going to get the X squared, just from substituting from this E row. The reason why I really advocate these IC tables is that it's designed to keep you from confusing yourself or trying to make jumps in reasoning. These two rows are equal to each other. So this is an algebraic row, this is a numeric row. If you're being asked to find the concentration numerically, it's going to be this row. So this will tell you how this concentration is connected algebraically to your extended reaction. Now as for finding the ethics workshop, and I'll do it as a student. So you're going to quizzes and assignments. Oh, because my student account is missing a whole bunch of stuff, that's why. Quiz assignments, the ethics workshop. There is an adaptive release associated with this. You're going to need to click that you reviewed the introduction. Again, I can't see it as a student because of how Access is set up for me. There should be a Word document here that's available to you. Tell you what. How odd. So hopefully you should be able to see it now, but there is a Part 1 Henrietta Lacks. This is a Word document, and if you download it, this Part 1 here are just the questions for it. The reason you get 2 submissions is if you click on this by accident. But again, the actual case studies here, you're going to read it, and then you're going to get this case study too. And let's go ahead and get rid of that adaptive release while we're here. Okay, actually we're going to leave that on. So what's going to happen is that you can't see case 2 until you submit the Part 1. Once you submit Part 1, then you should be able to see Part 2. And the same thing should be true for the submission as well. You can't submit anything, or you can't see how to submit anything for the Part 2 until you've submitted something for Part 1. But yeah, you can just look up the case as well. I mean, Henrietta Lacks is a pretty popular case study. Let's see. So let's see what's going on with the adaptive release for Part 2. Let me see what's going on with the adaptive release first, because this can get kind of weird. So can you still not see the second case study? And while I wait for Samantha's response, what do you do for pressure dependence reaction where the reaction has one gas phase reactant and one solid phase reactant? Number 3 on the pressure dependence web assign. It's the same thing. You just take the number of moles of gas on one side and subtract out the moles of gas on the left side. You're going to end up with negative numbers for pressure dependence. So this wasn't true of reactions because we didn't have a ratio. But for equilibrium reactions, we can definitely get negative pressure dependences. So I think for that one, you've got a CO2 on the left side, but nothing on the right. So it's 0 minus 1, and that will give you a -1 pressure dependence. You just ignore the non-gas phase ones. They don't contribute to the pressure dependence. Paper retractions underneath it. Oh, I hate you sometimes, Blackboard. Okay. All right, let me know if you can see it now. So when the semester started, I had already had the course shell set up, so this way it would all be ready to launch. And there was some weird update they did to Blackboard, and it created this group that no one can belong to. But if you had adaptive release set, which is what we had to do at the start of the semester for everyone, so you would have to take the entry exam, it made it impossible to access any of the course resources. So what I saw on my end, and pretty sure, yeah, you're just seeing the camera, there's this weird thing that says no member can be a member of this group, and it's like, why on earth would we have that option? But it's something about how when they update it for the summer semester right before classes started, if you had any adaptive releases set up where something else had to be done before anything you could do the next thing, it immediately put that within a group that no one can access. But yeah, you don't have to worry about, like, Henrietta Lacks is a pretty popular case, and that's why I do the part one. It's a pretty popular one. So if you had to Google it, that's fine. Again, you get 2 submissions, and the whole reason is in case there's any issues with submissions. The ethics are not meant to be like an intense thing, just more for you to like be reflective on. In hindsight, I'm glad I picked the case 2 study I did this semester, particularly with so many of you having to go back to NC State and UNC, despite them not being able to like test all of you for coronavirus. So this should be an interesting look into how universities operate. Hey, you're very welcome. Yeah, UNC can claim whatever it wants. I mean, they may mean test as in like take your temperature, but as far as I know, there's no way to. NC State, I know, has enough students to basically swing the votes in Raleigh. I'm assuming UNC is the same way, that there's like tens of thousands of students, and how on earth you're able to administer more tests than have administered in the state of North Carolina since the start of this, I have no idea. Especially, I think they're quoting 2-week delays on the tests. So, we'll see. Wake Tech is only doing seated labs, and even then they're hybrid labs and only for organic. We're not going to take any chances this fall. But again, we'll see. UNC and NC State both claim they're opening back up this fall, and then purportedly they're going to test everyone. I mean, I don't know. I mean, UNC's student health is better than NC State. I mean, NC State's was pretty bad. At least UNC's student health is tied to a real hospital. But I also remember there being a stark difference between the student entrance to student health and the like not student health entrance to student health. All right, other questions? So the way to find the, I'll bring up the homework for that one. Pressure dependence. And I'll bring up my desktop for you to see. So the pressure dependence here is basically saying that if we were to look at Q and we use pressures instead of concentrations, what would be the power on the pressure when we finished? So big picture, what we do is we look at in this case we have calcium oxide plus CO2 gas goes back and forth to calcium carbonate, solid. And Q in this case would be, since solids don't appear in our expression for Q, just 1 over the concentration of CO2. And from the ideal gas law, we get that the pressure times the mole fraction times volume equals the moles of I over RT. So we get the mole fraction of I, P naught over RT equals moles per volume, which is defined as molarity. So we can make this substitution. The concentration of CO2 is just the mole fraction of CO2 times pressure over RT. And what we would get in this case is that we get RT over X of CO2 P naught. So in this case, pressure, it would be 1 over pressure, or P to the negative 1. So this is where that exponential comes from, is to say that if we start substituting out all the gases with the expression, the mole fraction of that gas times the pressure over RT, what do we finish up with? Now this is the long, hard way to do it. The easy way to find the pressure dependence, let's say we're going to raise P naught to some number N. N is the moles of product gases. Minus the moles of reactant gases. So if we look at this reaction, we have no moles of gas on the product side. On the right side, we've got 1 here, but we don't have any here. So our moles of product gases is 0. And we have 1 mole of reactant gas. So this gives us N equals negative 1, which is what we got up here. But again, what that exponential is meant to represent is basically, as we change pressure, which way does Q go? In this case, if we have a negative pressure dependence, as we increase pressure, Q gets smaller. If we had a positive pressure dependence, so let's say we flip this reaction around, CO2 is on the right side, it means that Q would go up as we increase pressure. And it just has implications of which way it shifts in terms, which way the reaction would go if we increase pressure. So it's kind of a proof of Le Chatelier's principle. But as far as solids, liquids, and aqueous, they all disappear because they're not gases. We only consider the gases in this formula. You're welcome. Correct. So for question got asked, if we have N2 plus 3H2 goes back and forth to 2NH3, what's the pressure dependence? You're correct. There's 2 on the right, 4 on the left, so it'd actually be -2. So we have 2 on the right, 4 on the left, so 2 minus the 4 will give you a -2 pressure dependence. Correct. Moles are products minus moles are reactants. You're welcome. I'll wait for y'all to ask your questions. I'm going to work on a problem on the board. Not related to anything you're doing, just a curiosity for me. Any other questions? So Blackboard is going to automatically populate your test grades. It's not going to populate your lab grades until the end of the semester. The reason is just purely practicality. In order to tweeze out your lab grades, I would have to manually pull out your grades from WebAssign every single time. Some of you are just not getting your lab kits. Some of you have had your lab kits for a while, and because of that, some of you have like no lab grades right now. Some of you have a lot of lab grades. So really the test is the bigger indicator anyway. Traditionally in courses like this, the lab grade brings you up. So if you're kind of writing a C after the third test, you're probably going to pass the class because the lab grade does bring you up. If you're writing a high D, there's a reasonable chance that you'll probably do just fine in the class. But yeah, particularly with how the lab kits ended up working out this summer and just the sheer practicality of it, WebAssign does not it gives you a grade in the class for your WebAssign grades, but it doesn't make a distinction between lab grades and homework grades. Because of that, you don't have a lab grade quite yet. Even if I were to post a lab grade for you, it wouldn't be quite meaningful because you've only done half the labs and you're still missing the oral presentations, you're still missing your lab notebooks, which are going to be a big chunk of that grade. So I would focus more on just your test grades. Ultimately, those are going to make up over half the grade, 48% anyway. And then, by then, you should also have a pretty good feel for how you're doing on the labs anyway, just based on the feedback you're getting from WebAssign. So again, yeah, if you're kind of like pulling between 90 and 100% on the lab assignments you've turned in and what you're seeing on WebAssign, you're probably going to watch your grade go up when the lab grade gets factored in. But traditionally, I don't keep a running lab grade just because, again, so much of the grade is not in right now. It counts for 25% of your grade, so yeah, the lab's a big chunk of it, but since you've only got like half the lab in, actually at this point you got less than half the lab in, you could radically shift your grade depending on how you perform for the rest of the course. Blackboard is only showing your live test grades. That's it. not seeing much more in terms of questions today. So just a reminder, again, you've got until Tuesday next week, practically 10:50-ish, but like please don't wait until like the last minute to take it next week. I'm going to give you the extra couple days just because this is hard material. I do want to give you time to go over it. Again, feel free to email me any questions you have. We've got one more live stream tomorrow. The homework is due today just to kind of get you motivated and to kind of get you to take the exam this weekend. But again, you have until Tuesday. So live stream tomorrow. Please email me any questions you have. Free to answer them. Otherwise, I will see some of you tomorrow and hopefully y'all next week. Thanks to everyone that was able to show up today, and yeah, see y'all later.